Welcome to a new deep dive exploring everyday science questions. Everything we discuss comes from Alessio Guarino's book, 100 Everyday Science Questions Answered.
That's right.
And today we've got one that's probably hits home on those really sticky summer days. If the humidity gets to 100%, will I drown?
Yeah, it's a question you might definitely wonder about. That really heavy, almost thick feeling in the air, it kind of makes you think, well, what if it was all water?
Exactly. Like, could the air just turn liquid? So let's start there. What's the actual phenomenon we're talking about when we say 100% humidity?
Okay, so the phenomenon itself is just air containing water, but specifically as a gas. We call it water vapor.
Right, vapor.
And when we hit 100% relative humidity, that's the key part, it means the air is holding the absolute maximum amount of water vapor it possibly can at that specific temperature.
Ah, okay, so temperature is crucial.
Absolutely. It's a ratio, it's how much water vapor is present compared to how much could be present at that temperature. It's not like the air volume is suddenly 100% water.
So definitely not turning into a swimming pool, then.
Definitely not. Maybe diving into the physics helps clear that up.
Yeah, let's do that.
So water has three states, right? Solid ice, liquid water, and this gas, water vapor.
Mm-hmm.
Evaporation is just liquid water turning into that gas and mixing into the air around us. But the air can only hold so much of this vapor. There's a limit.
The saturation point.
Exactly, the saturation point, or sometimes called vapor pressure. And importantly, warmer air can hold significantly more water vapor than colder air. Its saturation point is higher.
Okay, so relative humidity is like a percentage of fullness.
Precisely. It's the actual amount of vapor in the air divided by that maximum possible amount for the temperature, then times 100. So 100% means it's full for that temperature.
Yeah.
But here's the fascinating bit and why you don't drown. Even at 100%, that water vapor stays a gas. It won't just condense into liquid water unless the air cools down below what's called the dew point.
So it needs a trigger, like cooling.
Yeah. At 100% humidity, it just means the rate of water evaporating into the air equals the rate of water vapor condensing out of the air. It's a balance.
Okay.
Think of it like this. At, say, 25 degrees Celsius, which is 77 Fahrenheit, 100% humidity means there's about 32 grams of water vapor per kilogram of dry air. Sounds like a fair bit, maybe?
It does, yeah.
But it's still spread out as individual gas molecules. It's nowhere near enough to, form puddles in the air or flood a room.
Okay, that makes a lot more sense. The physics explains why it stays a gas.
Yeah.
So if we're not drowning, what does happen? What's that feeling at 100% humidity?
Well, the main thing you notice and feel is related to how your body cools itself.
Sweating.
Right. You sweat, the liquid sits on your skin, and then it evaporates. That evaporation process takes heat away from your body, cooling you down.
Simple enough.
But evaporation needs somewhere for the water to go. It needs air that isn't already full.
Ah, and at 100% humidity, the air is full.
Exactly. It's saturated. So your sweat just doesn't evaporate, or it evaporates incredibly slowly.
So it just sits there.
It just sits there. That's why you feel so hot, sticky, and just generally uncomfortable. Your body's natural cooling mechanism is basically shut down or severely hampered.
Okay, so the danger isn't drowning, it's overheating.
Precisely. Especially if it's also very hot, your body can't regulate its temperature effectively, and that can be dangerous, leading to heat exhaustion or heat stroke. But you're not breathing in liquid water.
Got it. So just to summarize for everyone listening, 100% humidity feels terrible, makes it hard to cool off, and can be risky for overheating.
But you absolutely will not drown. The water's still a gas.
Good to know. It's uncomfortable, not submersible.
Right. No scuba gear needed.
Okay, excellent clarification. And maybe something for you all to ponder. Think about how on a cold day, even if humidity is high, it feels different than a hot, humid day. That's because the total amount of water vapor the air can hold changes so much with temperature.
Yeah, that temperature factor really changes the experience, even if the relative percentage is the same. Something to mull over next time the weather report mentions humidity.